Look at that, right on time. Hello, everyone. Hello. Okay, I'm here to talk to you about code quality. This is an opinionated talk, and I don't expect all of you to agree, especially Dan Aykroyd at the back there. My name is James Titcumb. I have done PHP stuff in the past. I work for this company called Rove. We do lots of consulting, development, training, all sorts of things, and generally we tend to end up working on big enterprise applications, which can sometimes be a mess, and sometimes we start them from greenfield and they're not a mess. So I'm also on the Zen Framework Community Review team, so that basically means once a year I might look at a pull request. Otherwise I do contribute to many other open source projects. So this is how we do code quality, right? We will put usleep with the build number in, and then when the boss complains, oh, it's going really slowly, you take it out, and then you get an instant win. Woohoo! Profit. Okay, maybe not. So, okay, before we dive in, we need to ask ourselves, what is quality? What does it mean? Maybe it's like one of these precision-engineered laptops. Quite sort of meticulously made. There's a lot of attention to detail. It's quite finely crafted, some might say. Or maybe it's like one of these. This is a fairly durable Land Rover, a British car. Maybe good or bad, I don't know. But they're built with quality components which are designed to resist mud and rust and things like that, hopefully. And they should last a long time. Or maybe it's like carpentry, right? You do things by hand and you put a lot of hours of painstaking detail in, and if it's anything like my carpentry, it'll probably go wrong several times. But you persist, you keep at it, and you put a lot of love and care into it. So quality. I think we need more of this in software. Not just PHP applications, but a whole software stack. I've had discussions with my colleagues before, and we agree that the best code is no code at all. This quote from Jeff Atwood mirrors that exactly. But we need to be practical. We can't just not write any code because we'd get fired very quickly. If only. Trade-offs we have to make, therefore. That was very Yoda. We need to make trade-offs, therefore. That was slightly more English. And I would also say we don't always need to write high-quality PHP applications. For example, prototypes or stuff that you know for a fact is going to be short-lived. That's not like, oh yeah, it'll only be live for a week, it's fine. Stuff that you know is only going to be live for a week because it's bound by a date of some kind. Some kind of a quick brochure website, you know, just sign up and registration, harvest a load of emails that you'll get into trouble with GDPR very soon, whatever. You build these for stability, right? For a short amount of durability. Maybe I would even say you don't need to write that many tests for it. But you can use tools that expedite development as much as possible. And, you know, writing those prototypes, which you know you're going to refactor because you always refactor prototypes. But I'm not talking about these today. I'm talking about products, right? Exactly the kind of stuff that Ian was talking about. It was Ian, right? Ian was talking about just a moment ago. These long-lived projects that have years on them, right? And more often than not, and I would probably say actually all the time, we do need to pay attention to quality. These in-house projects, these products, if you like. And what I find quite interesting is that open source software, in my experience, is almost exactly like these kind of projects. And you use the same skills on a long-lived software product as you do an open source project, because funnily enough, they're both the same thing. They're both long-lived projects that lots of people rely on, right? So what's quality in applications? It's not just about writing pretty code. It's not just about writing code well. It's about the whole process, the whole software development lifecycle. From planning, the development itself, documentation, testing, automating lots of stuff, code review, and of course your deployment practices. Now, I would be very impressed, perhaps, if one person in here raised their hand and said, we do everything perfectly. Because we don't, right? We always want to get better. That's what we're trying to learn about. So what about the cost, right? There's a lot of stuff to do. There's a lot of stuff to think about. And I'm not going to lie, this stuff does take time, especially if you don't know about it yet. Oh, I don't know how to use Behaviour. I don't know how to use PHP Unit. Things like that, right? It takes time and investment up front to figure out how these things work. And time is money, right? This quote sums it up nicely. A freelancer at $25 an hour for 100 hours still costs more than a freelancer at $150 an hour that takes 10 hours to do exactly the same task. From Brandon Savage. Brandon Savage is if you've not heard of him, he's another developer who does similar kinds of stuff to us. He's also written some books and things. But this sums it up very nicely. And it's about getting an expert in, right? Sometimes it might just be that kickoff to say, right, how do we use this thing? And, you know, the expert will show you how to use this thing and set you off on your way. Sometimes it might be, we don't have the resources to do this in-house. Please help us hire an expert. You know, that doesn't necessarily mean hiring Rove, although you should. But it means getting someone in who knows what they're doing, whether that's a full-time employee or a contractor, whatever. It doesn't matter, or just training sessions. It's fine. Getting things done right the first time is always going to be cheaper. Don't wait until everything's on fire. And a good expert will be able to train you. So, you know, if you get a consultant in, they should be good enough to show you the ropes, and then you shouldn't need to contact them much after that. So these tips and tricks are designed to work with high complex software projects. They're long-lived projects, like I said, kind of similar to open source projects. And funny enough, I think the best way to improve your attention to quality in applications is by working on open source software. I'm a big advocate of open source software. I write some, I use some, we all use some open source software, at least PHP and something on the stack, right? Maybe a web server of some kind. And I'm going to give you a disclaimer before I carry on. Hopefully not all of this is new to you. You know, some of the more experienced developers will be like, oh yes, that's right, James, I already know that. But I am hoping that some of you will get some good advice out of this and become yourselves a better proponent for better quality software in your craft. So I said it's about processes. And it is. And there's no secret to building quality applications. I'm not going to reveal to you, oh, actually you have to do this thing you've been missing out on the whole time. That's not the case. This is all stuff we should know. It's stuff that we've known in the software development industry, not just in the PHP community, but for years, right? It's about setting and following these processes, but also having the experience to be flexible enough to know when to break those rules and say, oh, actually, we can cut this corner because we know it's not going to bite us. But that's where the experience comes in, is you have to know it's not going to bite you back in the future, or you know you're going to fix it in the future. And as we know, that almost never happens correctly. So, those processes, I've kind of listed them already. Planning, development, testing, continuous integration, code reviews, and deployments we're going to have a look at. Planning is the first one. Something that is absolutely integral to writing a really good software project. And often it's not done in nearly enough detail, and sometimes is overlooked completely. Oh, quick, let's go fix this thing. Okay, great. Tap, 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 tap. Great, it's fixed. It's not how it should work. We need to think about what we're trying to do. And to do that, we need to communicate. Planning, effective planning, is rooted in good communication across your team, not just spoken communication. Emails, documentation, things like that, all forms of communication build this big picture of a good communication, right? Using the business terminology as well. Now, I'm hesitant to turn this into a DDD talk because it's not a DDD talk, but this concept is taken directly from domain-driven design. When you're planning stuff, you need to be strict on using business terminology. And the reason for this is because when you talk about how you're going to detect MIME types and store the XML in S3 and use a SAX parser to extract things, it means absolutely nothing to the business. And if it does, there's something really wrong. Instead, we need to talk about how the user can upload their bank statements and we can reconcile the transactions so that we can just send off our VAT return or something like that. That's much better, right? That means something to the business we're working for or with. And it also allows the business stakeholders, the people who know about how the business works, to interact and communicate more effectively with us, the developers, who may not necessarily know much about VAT returns or reconciling bank transactions and so on. So instead, we need to get into their world. We need to figure out what they're talking about and use their terms, and don't just sort of revert to saying, great, okay, so we'll pass this CSV and blah, 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 because it means nothing to them. And you'll start blocking them out of your conversations. So don't use this jargon. We use clear terms that everyone understands. This is called ubiquitous language. If you're familiar with DDD, you'll know that already. So once we're getting a good communication going, we need to be able to explore and discover much further than we think, right? We need to build up a comprehensive picture of what's being asked of us. Especially as a freelancer or a consultant, I will come into a business sometimes not knowing anything about the business. And I need to understand the business as quickly as possible. So I have to do this by talking their language, right? Whoops. TV goes over. So don't accept a request at face value and just say, great, okay, we need to add this thing. We need to understand the motives. Why are you trying to do this, right? What are you trying to achieve? You know, what's your ideas about going about it? And bear in mind that sometimes their ideas about how to go about it may not be the best way to go about it. So we need to explore and discover possible options, right? Discover those deeper specifications that are hidden usually, because we need to eke that information out of them. The most important thing is why, you know, the intent of what's going on. What's the intentions of the business? So quite often I will come to a business and say, right, let's have a workshop and say, well, let's explore what your business is doing. And it's nothing to do with software. Anyone can do that. It's having a chat about how the business works, all right? But we're learning about how the business problems are going to be solved the best way with software. So we need to be able to build a model of this business, right? So it's not a physical model. We're not building Games Workshop miniatures or anything like that. It's a shared mental model, right? It's intended to show and discover how this business works. So whether that's done with visualizations, right? Drawing on a whiteboard, things like that. Or whether it's through documentation, they send you a big boring spec sheet, whatever. Hey, that's better than no spec sheet, right? But we also need to be able to distill that conversation down and say, well, what is the important stuff they're trying to communicate, all right? So how? Well, yeah, we can do something called event storming, perhaps, right? Which is basically sticking a load of post-it notes on and figuring out what things happen in the business and when and how and things like that. We could draw things on a whiteboard. This place, Bright Pearl, has lots of whiteboards around, which is great, right? Because whiteboards are great. You can rub things out. You can have a communication. You can have this conversation around the whiteboard. And it's easy to rub things out and say, no, that's wrong, and add to it. And it gets very messy, but hey. And it flows with the conversation, which is nice, right? Once we've done that, then we can sort of digitize this, right? We can create these diagrams digitally if required. It's not always required, but it may be useful because these become more long-lived and these can become part of your documentation. Hey, we're starting to document stuff and we haven't even written any software yet, which is great, right? Because how many of us love writing documentation? Shut up, Dan. I said you're not allowed to speak this whole talk. The model must be fluid, though, because businesses change, right? We can't just build a piece of software and expect it to stay the same forever, because believe it or not, things do change when businesses change, right? So the model, and therefore your documentation as well, needs to be dynamic. We need to be able to change things as we go along. And as we all know, outdated documentation is not very useful. So, on to development now, right? We're good at development, right? This is the part we're good at with developers, probably mostly, I think. Maybe some DevOps people, I don't know. We need to care about code, right? I said it's not just about code prettiness and layout and style and things like that, but that is an aspect. Style, layout, structure, consistency, and precision and things like that. Think about other professions, right? If you hire a plumber, right? I've got a hole in my shower at the moment that leaks through into the ceiling if I use the shower. Thankfully, it's the main bathroom shower and on street it still works. Anyway, I'm waffling. If we hire a plumber, I expect them to clean up after and sort of put the holes back and things like that so that it's not a messy job. Do they leave sealant everywhere and things like that? Hopefully not. What about an electrician? Are they going to sort of wire everything up and then just leave the cables dangling everywhere? I hope not. So why as programmers do we feel it's okay to go ahead and write a load of code that's messy and means nothing to the next person that comes along? Because I hear it from the electrician we had in our house saying, this wiring is shoddy. You know, this was obviously done a long time ago before we had these modern electrician standards. You can tell I know a lot about electrics, right? So why do we leave sloppy code lying around? We shouldn't. This well-known phrase in programming, there are only two hard things in computer science: cache invalidation and naming things, attributed to Phil Carlton. Naming things is hard, and of course there's variations of this where there's off by one errors and so on, whatever. Naming things is hard, it's really hard. It's a balance of being descriptive and concise about what you're trying to describe. Simple bean factory aware aspect instance factory is an example from Sprint framework in Java. It's descriptive if you know what a factory is, or you know what an aspect is and a bean is, you know, sure. Or what about a class called loader? What does it load? Why is it loading whatever it's loading? It gives nothing away. It's completely the opposite. It doesn't give the intent away. Intent is that key word. I think the key to this balance is to describe intent. Ask yourself, what does this thing do and why does it do it? If the answers aren't clear, maybe we haven't planned well enough. So maybe we need to go back, look at our model, find out, and if it's not there, we need to open discussion again and say, what are we trying to do here? Because this is not clear. Right? When you do the planning, you should have almost written the software already, and you're just typing it out essentially at that stage. There is a quote from the DDD book author Eric Evans, give awkward names to awkward concepts. And that basically means if it doesn't feel right, think about an awkward name for it, and it's okay, and it doesn't feel so final. And that allows you to refactor it. And the point, this quote is from a talk, and the point that Eric is trying to make in this talk is that software is not perfect, just like the business processes aren't perfect. So if the business processes aren't perfect, that's going to be reflected, or should be reflected one-to-one, in the software that we write. And then when we perfect those business processes, we can then go and perfect the software as well. There's Solid, right? Who doesn't know Solid? It's okay to raise your hand if you don't, right? I'm not going to bash you or anything, right? These are a solid set of principles. And there's plenty of talks out there, so I'm not going to go through it, okay? But this is just a concept. If you don't know it, look it up. Keep it simple. And this is something I advocate in at least another one of my talks, is to keep things simple. We as developers, generally, I'm generalizing here, seem to have an overwhelming desire to overcomplicate things, overthink things, and over-abstract things. And I would challenge that and say, actually, we need to be avoiding complexity like this at all costs, because it means more testing, more documentation. We should have planned more probably than we have, and maybe we've missed the point of what we're trying to do by just over-engineering things. Who has not heard of object calisthenics, this concept? Okay, lots more hands, cool. I'm not going to tell you much about what it is. I'm going to tell you to go and watch a talk by Raphael Domes about object calisthenics. And it is things like, there's these rules, right? Like 1 level of indentation per method, avoiding using the else keyword, wrapping primitive types always in strings and things like that. Collections as first-class objects, not just using arrays everywhere. One object operator, so obeying properly the law of Demeter, the principle of least knowledge. If you don't know what I'm talking about, go and watch the talk, okay? All right, it's a great talk and it will sort of explore these concepts. Raphael Domes, D-O-H-M-S. Maybe we can tweet out the link after. So I mentioned about abstraction because of complexity, and we need to avoid early abstraction, right? We're told lots and lots of times, don't repeat yourself, DRY. But I believe there's more nuance to it than this, right? There is a careful balance between early abstraction. If the model is not clear about where abstractions happen, then don't do it, right? Don't create those abstractions. A quote that sums this up nicely from my colleague Marco Pivetta, like him or loathe him, code for your use case, not your reuse case. And that basically means don't think about every possible scenario that could come up and make sure that we future-proof the program, because those scenarios probably won't happen. Just code for what you're trying to do. Solve the problem right now, but solve it in a way that you can look at later and say, I know what's going on here and I know how we can refactor it. If you write it in a way that says, oh, I don't know what's going on here, then we've screwed up somewhere. So care about your API. Keep your class's public API, not like web services and stuff, right? This is each individual class's public API is hugely important. Keep everything private by default unless you want to expose it, right? Properties can keep state and things like that. And your public methods should always accept and return strict invariant types. That is to say that a type you give an object is known to be always in a valid state. We'll have a look at that in a moment. Another appropriate quote about your public API is a public method is like a child. Once you've written it, you have to maintain it for the rest of its life. Quote from Stefan Priebsch back in Berno PHP 2014. And that's exactly right. And this very much applies in the world of open source, because how many times have you complained about, oh, this thing's broken backwards compatibility? And that's because we're not obeying these rules. So strict typing matters, right? In PHP 7 and above, we have strict scalar type declarations. They're great for various reasons, right? IDE introspection and so on, because doc blocks we know can be wrong. Easy readability and expectations on parameter and return types. And actually, I believe the most valuable part of the type declarations that have been introduced in PHP 7 and 7.1 is that we can specify a return type. Because if you're using strict invariant types and value objects and things all over the place, you could do that anyway, because we've always been able to use an object as a type declaration. Not always, but for a long time, right? And it's controversial to some, but I would encourage using strict types for everything new, because we want to know exactly what we can and cannot give to a method. And our types, return types, parameter types, and things like that, give us those expectations very clearly and say, I want an email address. I return an email address, whatever. So value objects are very useful in this regard, right? And actually, like I said, we've been able to use these for quite some time in PHP as parameter types. It's just now we can also use them as return types. A value object, if you've never seen this kind of concept before, is basically where you encapsulate a single value in an object, hence the name value object. Whee! Consider a UK postal code, okay? Most of us probably know what they look like. And the validation is done when you construct this object. And aside from a few brutal magic ways, there's no way of changing the value of this. And there's also no way of doing anything but casting it back to a string, in fact. I mean, there are ways, but don't do them. And you can use assertion libraries and so on to make sure that we match this regex, and it's a very long regex and so on. But the point of value objects is they give you consistency and those expectations, right? And we can therefore say that, assuming that we've done good validation in that value object, that whenever you have a postal code object, it will always be in a valid state. It will always be a valid postal code, right? So on the first call here, I don't know if you can see it at the back, it's maybe a little bit small. We're calling assign postal code and we're giving it a number 12345, which is invalid. That's not a postal code. So it will throw an exception. It means that we never reach that assign postal code method, which expects a valid postal code, right? So we're ahead of the time we're even using that postal code. We've failed the validation. The second call is valid. We can get a string with a postcode from Portsmouth. And the third one will fail because we're giving it an integer. And obviously with PHP 7 and strict type declarations on, that will now give us an error. So testing. Testing. We all know about testing, right? Who is happy with the amount they're testing? Really? We're all testing things every day, right? Do you write software, throw it over the fence without even checking it? Right? Did you put your hand up, Dave? I'm never hiring you. We're all testing our code. It's just we're doing it manually every time, right? We'd make a change, we refresh the page or run the command again, right? We're testing things manually. That's kind of the usual process of development, right? So, now this is the question you probably thought I asked. Who is happy with the amount of tests that they've written? Okay, that's the expected answer. Who wishes they could write more tests? Look at all those hands go up. Who doesn't write any tests? Some people. Okay, so how do we go about this? Testing is not a separate line item, right? The often quoted thing I will hear is, oh, my boss doesn't give me extra time to write tests. If you're new to testing, right, there is an initial learning curve which will feel like you're dragging your heels in the dirt. It will feel slow. Once you're used to it and once you know what's going on, you will actually improve much quicker. You will be able to write code faster. You will be able to improve the quality of your applications, right? If you are working on like an in-house project, a product type thing, right, and you're a full-time employee, the sneaky way I've found kind of works sometimes, depending on how strict your company is, right? It works well sometimes. The sneaky way is just to write tests and don't tell anyone about it. That's pretty much it. Even if you haven't got continuous integration, blah, 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 if you can run those tests, you can alert someone to some code that they've broken, right? And as soon as you start doing that, you'll figure out that there's value in writing these tests because you'll discover bugs, right? I strongly, firmly, adamantly believe that you should not need permission from your superior or your client to write tests with your software, right? Would you buy a car without assuming that someone's tested to make sure that car's not going to crash if you press the brake pedal? I hope not, right? We expect these cars have been crash tested, right? And the manufacturing process will be good, we hope, right? And they'll probably pluck some cars off and crash test them. I don't know how this testing works. I don't make cars, right? But I do know about software, all right? We all write software. So why do we deliver software without writing tests? I don't know. The fun thing is you're already testing. It's just you're doing it manually, right? So the key here is just to automate that because it's much quicker for a computer to test your software than it is for you to do it. That's a fact. So once you've learned the tool and how to do this, it will be quicker, right? So we need to automate that. Do you still need convincing? Tests are proven over and over again. And there's so much resources on this. I don't need to go into too much detail, but you will find there will be less bugs. There will be less regressions. It forces you to think about how you're designing your code. If you've got this legacy mess from 30, well, maybe not 30 years ago, I don't think PHP was around then, from 10 years ago. Yes, you've got a legacy mess, but you know what? Testing is still possible. It's a bit more of a challenge, and I'll introduce an aspect for that shortly. So how do we go about writing unit tests? On an existing or legacy application, you make a new rule, right? In your pull request or merge request, whatever you want to call it, process, you do not merge that until it's fully tested, right? Any new features will have tests with them. Any bugs that you've discovered and everything's burning down, don't merge the fix until a test has been written to make sure the bug doesn't happen again. You make this rule and you make it hard and fast, no matter the pressures that the business puts on you because everything is burning down. And you're saying, but everything's burning down. We're losing thousands of pounds. Or just write a test, right? Over time, your coverage of your code base will increase, right? And it's a really brutal way of doing it. On a new application, hey, the concept is exactly the same. It's just you're doing it at the start. So you've written tests for everything. Tests will allow you to spot complexity in your code, right? Hard tests to write are the result of potentially complex or smelly code. I say potentially because it's not always the case. It allows you to reduce the scope of methods, right? Unit testing is about testing the smallest amount of code possible. And we want to avoid big procedural methods that do lots of things because that makes it more difficult to test. So we want to shrink things down. And we want to break it into more meaningful, well-named operations that go back to the business model that we had at the start and match what we're trying to do in the business model. So say we've got this single method that's called process. It takes some stuff in and it's got lots of complicated code, right? The key is to avoid that and break it down into something more meaningful. So we've got a meaningful thing, a throw stuff into the fire and a combine string with fire and things like that, right? We picked a better name than process because that means absolutely nothing. And we're using words that describe this particular business. Maybe it's a stuff burning business, I don't know. And we can use those tips from the object calisthenics talk that I mentioned earlier to achieve things like single indentation, and that will force you to make smaller methods because you'll be like, oh, if I try and put this much in, it becomes more difficult. And that also reduces the amount of tests you need. So more complexity is more tests. Who knows what cyclomatic complexity is? Who knows how to calculate it? I don't. It doesn't matter. It doesn't matter. All it is just a number that is used to create this metric called a crap index, right? Change risk analysis and predictions. I think there's also another meaning for it, whatever, it doesn't matter. It's basically how much complexity you have in your methods. The lower the crap index, the better, right? Because you've got more tests that are covering that code, so there is less risk for that, right? So test coverage. How do we get 100% test coverage? Any ideas? No, it's the wrong question. Well, that's true, yes. That's not what you're supposed to say. Anyway, that's actually the wrong question. We shouldn't be asking, how do we get 100% test coverage? Because it doesn't really matter. We shouldn't be aiming for 100% test coverage. We should be aiming to cover 100% of our domain logic, the business logic that we've written, right? And that is separate from how we interact with Redis or MySQL or Postgres or some irrelevant AWS thing that we don't care about. That doesn't matter, right? Yes, we can write some integration tests, whatever. The important thing is how the software operates for the business that you are working on, right? Doesn't matter if AWS goes down. Well, it does, but anyway. And on top of that, it's really difficult to measure real coverage, right? Coverage is calculated by the number of lines executed, which is not strictly accurate. So basically, we're doing it kind of wrong at the moment. Xdebug, you may have heard of, supports this calculation of branch coverage, right? But PHP Unit doesn't, and it's really hard to visualize. Let's try and explain what I mean. In this function foo, which takes A and B, both booleans, if A is true, we'll echo A. If B is true, we'll echo B, right? A question for you. Can you generate 100% code coverage using these two calls? see shaking heads, but that's because I keep tricking you. You can. All lines are executed, but it's wrong, right? Because we haven't tested all possible execution branches. There's this one where you pass A is true and B is false with the purple line. Where A is false and B is true, you get a red line, right? So we've covered those two. But there's others. When they're both false, we get a new test that we need. We need to write through with false and false, and another one when they're both true. So actually we need 4 tests to cover this particular method. The issue is it's really difficult to display this clearly in a meaningful and understandable way, because this is a bit of a mess. So although the support is there in Xdebug, because Derek likes to implement great things, we just don't know how to show it nicely to you to make you understand you're not testing this execution path, ultimately. So we need to take steps to prevent coverage leaking as well. That is, when a test runs, we haven't properly constrained where the coverage should go. So when you are writing unit tests, perhaps you don't mock something out. It's up to you whether you do that or not. When that other class is called, we're leaking coverage, right? And PHP unit will show things that are covered when they're not supposed to be. They're not the focus of that system under test. So we use this covers annotation on the test, which says this is the class that we're trying to cover. This test can then, PHP unit will then constrain any coverage we do generate to just that particular class. And this allows you, by doing it on the whole class and not a specific method, will allow you to cover the private API of your class, or protect it, as the case may be, without using any reflection nonsense, because you shouldn't need to do that for most of the time. So, aiming for 100% test coverage is usually impractical and is also not a worthwhile goal. The point of tests is to make sure everything in the business domain is working, right? But if your tests are not performing correct assertions or appropriate assertions, then your tests are not effectively testing. So how do we test that problem? How do we help that problem? Sorry, I'm saying test a lot. It's okay. This is not a useful test, right? We're creating an event, we're creating a customer, we're purchasing a ticket. Great. This generates code coverage, but we're not testing anything. There are 0 assertions on here about what's going on. So for example's sake, we put in some assertions, make sure that the purchase ticket returns a receipt, and we check that the receipt is for the correct event and that the customer is listed on the receipt, and things like that. It's a very trivial example. But we can do better than that, rather than just looking at it. We can test that the tests are testing. Yes, indeed. We want to use something called a mutation testing tool. Who has never used a mutation testing tool? Okay. There used to be 2 in PHP, Humbug and Infection. Now just Infection, because Humbug is now deprecated. Infection PHP is a tool that you can set up in your CI environment, and it will run your tests. And it will change things in your source code when it runs the tests. And if the tests then fail, well, that's good, because your assertion has caught the fact that your tests fail. If the test still passes when you've changed the code, the test's useless. It's a very interesting tool. I mean, there is false positives and so on. But let's look at an example of what I mean, right? We've got an add function. It does what you might expect, right? It adds 2 numbers together. Very simple. We write a test. We do result, add 2 and 3. I've left the assertion commented out. The eagle-eyed viewers may have spotted. So this test is not effectively testing anything. Yes, we'll run the add function, and it will add 2 numbers, but we don't check that the result is correct. So, a mutation testing tool like Infection will come along and it will change things in your code and expect your test to now fail. But of course this test won't fail now. So this will fail this test. Infection will say this mutation was not caught. If we uncomment this, of course, now the test will fail if we change that sign to a minus, and that's good. So what about other tests, right? I've talked a lot about unit testing, which is kind of important. And I think it was Dave Liddman, you did a talk about the pyramid of testing, possibly here before. So some of you may have seen that, right? So there's other kinds of tests. There's your integration tests and things like that, right? This is where we test specific methods on a public API. We have some external infrastructure that may be important to technical people, but is not important to business people, right? Database, queues, web services, and so on. So integration tests is where we start pulling everything together using a real database. But we're not concerned with the domain logic here, right? We don't care about that. We just want to make sure that if this thing happens in the code, we want to see it correctly reflected in the database, for example, or we want to see these specific messages appear in a queue and things like that, right? Those are the infrastructure parts of things. And there's also behavioral tests, right? Sometimes there's an acceptance tests. I don't care what you call them floobs if you like. But this is where we can describe the business logic. And even more importantly than testing for this is that we're documenting how the business works. This is a bad test. If you're not familiar with BHAT, this is a bad test. Don't write tests like this. We're not testing any business logic here, right? This is basically a very fragile user interface test. It's also not very useful or readable. There's no meaning or intent about what's going on, right? As a business person who works in the airline industry, .bref IPT fuld means nothing at all to them, right? Unfortunately, this is how some people write tests. This is a better example, right? We'll look at what's good now. First of all, we're using this free text area at the top between the feature and scenario, and we can document business rules up here, or policies if you like. The scenario no longer contains any references to UI elements because the UI is not necessarily relevant to the business. Instead, we're describing the behavior of the business, of the domain logic. And additionally, if you're really good at BHAT testing, you may have noticed that I've simplified given, when, then into just given, when, then, which becomes much more relevant. If you have a given, when, then, and then like a when and then a then afterwards, it's not good, right? Basically, it's a smell that your test is not focusing on a specific behavior of the application. And finally, another important thing is that we're using a concrete example. And that allows us to discuss with the business what this test is doing. And it means something to them. We can say, oh, when we're taking this flight to OTP, I can't remember what airport that is, on the 24th of May, maybe the fare is different, so it has different outcomes. Or maybe they can't print their boarding pass from a particular airport and things like that. All right? And that allows you to have that discussion. And using examples allows you to do that. Why is this important? You are supposed to be testing behavior with behavioral tests. And that's probably the thing that we always dive into BHAT and say, oh, great, we can like click around in a browser and stuff like that. But that's not what it's trying to do. That's the irrelevant part of it. We're documenting how the business works. And the second part to that is we can automate that using tests, right? The point is we can discuss about what the test is doing, right? And the other important stuff is that we've written documentation in the application, and then we can automate them, right? Quite often, people will come into the application level and start testing the UI and things like that, and clicking around in browsers or headless browsers and things like that. But you know what? This is really, really slow. Who agrees with that? So why do we do it to ourselves, right? Test at the domain layer, at the business logic, right? It doesn't matter that much about the UI. It matters that the business logic is doing what it's supposed to. And if you've got that clear separation, that clear demarcation, we should be able to just invoke the methods that we're interested in on our public API. We can either use real infrastructure or mocks. I don't really care. If it affects you, then maybe use real infrastructure, or at least staging infrastructure, right? Testing via the UI if you've done Behaviour before, you will have seen stuff like this. We get the session, we get the page, we click on a button, we find a field, and so on. Using the domain layer is where we retrieve a booking using the reference given, and we have it and we store it locally. And that's much simpler, right? We're just invoking the code directly. We're skipping out the UI part of it. We're skipping out the actions or controllers, whatever you want to call it, handlers, responders, I don't care. That's not the important thing, right? We're testing the business logic behavior, not the UI behavior. And also JavaScript is a real offender here, because if you use fancy elements like select to and things like that, it's a nightmare to test. UI tests, you can still have some of them, right? But these should be very few and far between, right? Testing like the main happy paths through your application, and just have like, I don't know, however many is relevant, but just a few key tests that make sure that the UI is doing what it's supposed to. If there is a bug that happens and you need to be able to reproduce and make sure that bug never happens again, hey, write a UI test, right? It's okay to do that, right? You can run these in a separate Behat context, right? You can tag them with @UI or something that says run this also in the UI context, and it works. And these end-to-end tests are actually very useful, right? Now, I said earlier about testing legacy applications, and unit testing is a real pain in the bum to do that on a legacy application. So we can use UI tests to do that, right? A legacy application you've inherited, it's got no unit tests, no code coverage, whatever. Write a UI test that proves the application does what it's supposed to be doing. Write it in the nice, good behavior describing way, not in the UI way. But then obviously write the UI test behind it. And then you can refactor underneath and make sure that the business logic still works, right? Then you can start adding unit tests and so on. And that is quite beautiful, I think. So automating everything is really kind of key to this, right? We're creating a smooth, nice workflow. Continuous integration, right? Every single change must be tested, right? When you submit a pull request or merge request to your code base, it should be tested by continuous integration. Why? Because developers hate running tests manually. We forget to run the tests, and the tests might be really slow. I've worked on projects before where the end-to-end test suite was written in this UI way, and it took like 3 to 5 hours to run. I'm never going to run that locally because it's not worth my time. I mean, I could sit there and getting paid, but really, it's not very fair on the customer. Because tests cost money to run if you do it like that, right? Tests are invaluable, fact. But running the whole test suite manually, it costs money every time. So we get machines to do it because it's cheaper to pay a machine than it is to pay a human, right? We're actually automating ourselves out of a job, perhaps. That's not the case, that's nonsense. But if you're not automating this stuff, it is a false economy. Travis, right? I generally like to be unbiased and so on, but Travis is a really helpful tool, right? You configure the YAML, stick in a bunch of commands, done. And it runs every time you submit a pull request or merge request. Yes, there's other hosted CI services, fine. Use what works for you. But most important is use one that you don't have to do too much maintenance on, right? There is, of course, Jenkins. Yes, it's free. Yay, free. But it's not free. It's got this burden, right, of maintenance. It's open source software. Hey, James, you said you like open source software. I do. But Jenkins is really, really powerful and really complex. It updates, obviously, quite frequently as well. So it might break things, which is not good. So someone has to investigate, oh, it's all failing again. And it costs money to run these servers as well, right? Unless you have a really specific need for Jenkins, then I feel in most cases it's overkill. So use some of these hosted services like Travis or Circle, things like that. So what do we want to automate? Well, it's very simple. Everything. We have separate jobs for running unit tests, behavioral tests or acceptance tests, end-to-end tests, separate them as well. Coding style tests, you can automate PHPCS and things like that. Database migrations as well, that's an important one. Front-end builds with your JavaScript tests and so on. And anything else that is relevant to the application you're making. The goal is very simple, to have this red or green feedback, and that is it. If it's red, don't merge it. If it's green, it's time to code review. Code reviews are important for education, communicating, and gatekeeping rubbish software. That's it, right? If anything, code reviews, I feel, is one of the most important parts of good quality software. And the reviewer or reviewers must have the authority to prevent merges happening with rubbish code. Those reviewers should be reasonably experienced, I would say, as well. I'm not saying reviewing is not for juniors, because junior developers should be reviewing code. They should be trying to read code and understand it, because part of the problem is trying to read code and understand it. So what do we look for? Things like code style, right? Most of this, however, should be automated away. If it's not, do it. There's PHP Code Sniffer, PHP CS Fixer, whatever. You shouldn't need to do this. It pays to keep an eye out, right? We can't automate every single thing. And also avoid refactoring style and layout when you're also making a feature change. Create separate pull requests. Keep code changes small and atomic. Huge pull requests are a nightmare, right? And things will get missed because the reviewer will look through tens of thousands of lines of code and pick out some problems, right? And we joke about this. I've joked about this on Twitter before, saying, 10,000 line PR gets merged straight away. But it's true, because it's much harder to see the wood for the trees and all those nice idioms. Try and keep your changes focused and to the point, as small as possible, right? Dependencies, make sure you've got recent versions and so on, right? You can actually speed up composer updates by locking to the lowest possible version or the newest possible version you can use and updating them a lot more frequently than we probably do. Include a library called Rove Security Advisories. Don't worry, you don't have to pay for it, it's free. And it conflicts automatically with any known to be insecure packages. It uses the data from Friends of PHP Security Advisories and just generates a composer JSON that will automatically conflict with those insecure packages, so that hopefully you should never install them. We look for structure and good practices in code reviews, right? Have we got interfaces where appropriate? Is the class final where appropriate and not final where inappropriate, and so on. You know, generally the rule is if it implements an interface completely, then you can make it final. And that also encourages the use of composition over inheritance and blah, blah, blah. That's another solid thing, right? Type declarations should be everywhere if you're using PHP 7 and above, maybe 7.1 if you want to use void return types. And assertions for parameters. Maybe you can use value objects, right? You're passing an email address around in a string all the time. Maybe we can look at that and say, oh, actually, we want a valid email address all the time. So put that email address validation into a value object and pass that object. Tests. I think I've mentioned that one. Never merge anything without tests, blah, blah, blah. Use randomized values in tests that will avoid any potential weird global state issues. Do the behavioral tests you've written, the feature files, make sense? Do they read in good English? Which is not necessarily what I do all the time. Are they written using good discussable examples? Can a non-developer understand them? Because they should be able to. And documentation. Does this feature need documentation? Sometimes it may do, right? Maybe that's the post-it diagram that you made earlier. Maybe that's just a markdown document. I, more often than not, will document stuff in just a docs folder in with the source code so that it's there ready for any other developer to look at. Whether they actually go and look at it, that's a different matter. Markdown's great for that, though. Security. I mean, there's a whole load of talks just in that one thing there. We look out for potential security flaws. A good starting place if you're unfamiliar with security things is to look at the OWASP Top 10, which was updated this year. Look for things like SQL injection or SQL injection, depending on how you like saying it. Filter input, escape output, things like that. Make sure you've not got CSRF and XSS and blah, 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 right? And also insight. Do you get a good insight into what problem is being solved? For example, is the bug fixed that we're trying to fix, right? Does the feature work as expected? Actually try it out. Check out that code locally. You should be able to bring up that development environment locally, try that code out, and if it works, good, you checked it, right? Maybe you can run the end-to-end tests on it, whatever, right? Running tests on it. Does the naming make sense? Does it use the ubiquitous language? Blah, blah, blah. Things I've discussed already. Is it too complex? Is it too simple? And so on. It does take practice, right? When I first started trying to do code reviews, I was like, I don't know, it looks all right. And you'll probably find that if you've never done code reviews before, it's like, well, it's code. I mean, I wouldn't write it like that. I'd call that foo instead of bar or whatever. But as time goes by, you'll pick up on things much better, and you can apply your experience that you've learned to spot these problems developing ahead of time. And there's a real skill to also communicating this in an effective way. It's okay to be opinionated. I've just spent 56 minutes being very opinionated about some things, and I don't expect you all to agree with all of it, but as long as you communicate nicely and friendlily, and you are able to dissolve disagreements in a nice way, and that can be hard in itself, that's okay, right? Some of this is very mechanical, black and white stuff, right? That's right, that's wrong. A lot of code that we write, as we know, there's more than one way to do things, right? So it can be very opinionated. Best practices, like I've been burnt by things in the past, so I'll never do things like that before because it broke at this one time like 5 years ago, right? And we bring our collective experience together and communicate it with each other nicely. One last thing to very quickly touch on is deployments. Automate them, pretty much. We're automating everything. The goal is to be able to click and deploy, or type a single command and deploy. And the point is when we deploy to our production infrastructure, if a human is involved, there is a huge scope for doing it wrong because we screw things up. It happens, right? So the goal is to make your deployment process 100% reproducible. So you can just say deploy or deploy if you want to type it out. So to implement this, you take the steps that you do manually, you write them down in a manifest, whether it's a thing deployment thing, or Jenkins, or a bash script, or Heroku, or any other platform thing, and you make it reproducible. And that's it, right? And the goal is to always be deployable. And once we've got that process where we can just deploy at the click of a button, you'll notice that you can deploy more often, right? And you can do these atomic deployments, multiple deploys per day. There's this Facebook mantra, move fast and break things, which is of course dumb, so they fixed it. Move fast with stable infrastructure. Because you know what, breaking things costs money, and we don't want to cost the business money, we want to make them money. Otherwise, we're not paying for ourselves. My point is, if you make everything automated and that you're testing all the time, and you've got this pipeline where you submit some code off, it will get tested automatically. And then when it's been tested, you can review it. And then someone reviews it and says this is good or bad, and then it gets merged, and then it gets deployed. And all of that, or at least most of that process, is automated. And if your tests are passing, then you will increase the delivery confidence that you have, right? And you'll find you'll start writing more and more tests and aiming for this higher quality software, right? So the continuous delivery and deployment pipeline is, you know, if you want to deploy as soon as something's merged to master, that's fine as well, right? Some people get very nervous about it, like, well, what if something breaks? Well, the point is you have to be confident in that pipeline to be able to do that. So when you merge to master, that you know, or at least are fairly confident, that it's not going to break. Sounds pretty scary, perhaps, but it is possible. Maybe not today, But in the future, it's definitely possible. You just have to have the confidence in your pipeline, right? And if you're going about all of these processes and increasing the quality of your applications, so you're doing better planning, more exploration into what we're trying to do, what business problems we're trying to solve, if we're adopting better development practices like solid and object calisthenics and writing better tests, right? And we're automating that pipeline, that will result in better quality software. And that means a higher confidence in the software, confidence in not breaking things and delivering stable software, and also being able to deliver more features in a shorter length of time, which obviously makes the businesses happy, right? It means happy customers. And ultimately, there is satisfaction that you will get from delivering a great service, right? You will learn more. You will become a better developer for it. The end. I've gone over an hour, so probably don't have time for questions.
Couple of quick ones.
Right, okay, go on.
So say you've got an existing code base, not necessarily particularly legacy, but it's there, and you haven't got stuff in place, you haven't got the processes in place to ensure good quality. Where would be the first place you would start investing time to start making changes and improvements?
Depends specifically on the use, on what you're trying to do and what you're trying to achieve, but a good place to start is by writing like a UI test, and go through, click like the old school, click through, make sure things do what they're supposed to do, and do that from like the whole process. Obviously, if you haven't got a business process that the customer is supposed to go through, that may not be applicable, but more often than not, it might be. So write that test and make it runnable so that everyone's got the tools, right? If you need Selenium to run it, bundle it up. There's a composer package, SE Selenium Server Standalone, that you can include, and that bundles everything up, right? And you just run some scripts that should run on Linux, and you can run that test and make sure it works. The next step is to automate that into continuous integration. If you don't have continuous integration, then get it set up. So as I said, something like Travis is super simple to set up very quickly, very quick to get up and running. Obviously for private projects, yes, you have to pay, but that payment per, I think it's like $70 a month, is so worth it. It will save you the time of doing that manually. So that's the first couple of steps. And then it depends where you want to go from there, really. Yeah. Absolutely, yeah. It's just making sure like the core business thing is tested. And the quickest and simplest way of doing that is by writing a behavioral test, say this is what the business is supposed to do. And then you write the BHAT implementation and say, click this thing in the web, blah, blah, blah. If you've got mobile apps as well and stuff, you don't necessarily have to worry about that to start off with. But then obviously you can go and refactor and start adding more tests as you go on. Any more questions? I'll be at the pub, so go on.
Within your BHAT, you're making your features very small and then pushing all of the work into the feature context.
Yes.
So we find that our tester, you have a manual tester, but we're getting him to write and approve the BHAT test. He's not that coding, so by taking that long feature, which he understands and can interact with, into smaller code chunks, then we're actually making it harder for him to see what's going on. So is there any sort of approach where you can say, write your steps as a smaller BHAT test and include them in your big test? Or is it just the only way you can do it by doing it in the feature? And
I would highlight the fact that in that case, your tester, just like you, will go through things in a very methodical way and say, well, I have to click this button and I have to enter this in a field, right? That is what we do to test. That's how we test things, right? But the point of writing a feature file is not to describe how you reproduce that. The point of the feature file is to describe the behavior of the business, right? And the translation of how we describe the behavior of the business into how do we actually test that is indeed slightly more complicated.
so
So it's, I think,
Giving him more knowledge to understand the other bit as well as the bit.
exactly, yeah. I think perhaps some training might be.
And we've gone from no BHAP to BHAP, which has worked really well. We're now sort of 25-minute long test suite rather than 5 hours, but there will be a point where it gets too big for its purpose.
They can become very unwieldy. So it's
ass on a massive amount of occasions.
Good. Just one system. Excellent.
cool. Is that probably time? I don't know. It's up to you.
We're going to take a 5-minute break now. Thanks very much, James.
Thank you. Don't forget, joined in and all that jazz. You get prizes.